Good morning, Year 5. I hope you are all well. Today we're going to complete our last lesson of our area and measurement unit. So today we're going to look at the area of irregular shapes. Before we do anything, I'd like to have a go at doing these questions to warm up your brain before we start our lesson. Okay, let's go through some of the answers. So we know that a half out of half gives us a whole. A rectangle has an area of 26 metres squared and the length of one side is 1 metre. Therefore, we know that 1 times 26 is going to give us 26. Therefore, the longest side has to be 26 metres. 3a, the side of a square is 12 centimetres. Well, we know that a square has equal sides and equal lengths. Therefore, all 4 sides must be 12. Therefore, 4 times 12 is going to give us 48 centimetres. B, we're going to look at in a little bit more detail on the next slide. So here is our hexagon. A hexagon is a 6-sided shape. Now, the hexagon has the same perimeter as the square in 3a. This was 48 centimetres long. What is the length of each of the hexagon sides? So here is our hexagon drawn out in front of us, and we need to remember that this is a regular hexagon. Therefore, each of the edges are the same length. Okay, so if I was to indicate that on my shape, I would draw a line on each side. This tells me all of these sides are the same. So if we need to work out what one of them is, all we need to do is 48 divided by the number of sides. 48 divided by 6 is going to give us 8 centimetres. Okay, so we're going to be looking at working out the area of irregular shapes today. For example, this shape on here. Now, it's an irregular shape purely because it does not fit with the squares that are on the shape. So we need to try and work out the area of the shapes when they don't quite fit into all the grids or all of the squares. Now, I think a better way to phrase this question, rather than what is the area of this shape, is estimate the area of this shape. Now, we know that the word estimate means to make an educated or a sensible guess. So that's what we're going to do for today's lesson. So what we're going to do to start off with is we're going to start by counting all of the main squares that we have. Okay, so if we counted up the lengths of the full squares that we have the 6 full squares. So we know that 6 is going to be our starting base. What we need to then look at is we need to look at the squares that are slightly full. So here we have a square that is almost full. So we need to then add this bottom part and flip this round in the hope that it matches not far off a full square. So we can count this as another full square. Equally, I can do the same to the other side. Again, looking at the little bit that's just on the bottom of that shape. If we flip that round, that almost nearly gives us another full square. So we can count that as another one. Now, if we look at the 2 corners on each side of our shape that we have, we could look at those 2 as well. If we think about it, if we flip one of them over and we join the other one with it, it not far off gives us almost a full shape. Now, because it's more than half the shape, we're going to count that as a full shape because we are only estimating, so it does not need to be an exact answer. So we can count that as our 9th full square. Now, because our measurements are 1 centimetre by 1 centimetre, that means that the area of each square is going to be 1 centimetre squared. So if we add them together, we have 9 centimetres squared for the area of this irregular shape. Based on that knowledge of being able to count the whole squares and matching any smaller squares to make whole squares, pause the video and see if you can estimate the area of this shape. Okay, so again, we're going to count the full squares. So we have 2 full squares. Now here we have almost a full square and the additional part of our square triangle up here. If we flip this over and join it, it near enough makes a perfect square, so we can count this as a 3rd square. I'm going to do the same with the bottom shape. With this additional part here, if we flip that over and join it on, that almost makes a perfect square again. So we can count this as our 4th square. Again, the same unit of measurement is 1 centimetre to 1 centimetre, so multiplying them all together by 1 would give us the 4 centimetres squared. See if you can have a go at thinking about how we might possibly work out the estimation of the area of this very peculiar shape. Well, let's start off the way we usually would. Let's count all the full squares. We have 1, 2, 3, 4. If I count the bottom row again, 5, 6, 7, 8, I have 8 full squares altogether. Now, if I look at these squares here, these pretty much take up both parts of our square. So we could probably count these ones here as being full squares. So this would be 9 and 10, and we could count this as 11 and 12. Now, the only thing we need to look at is the missing areas we have on the top left and the top right of our shape. So if we were to add these two parts of our shapes together, that's going to give us 2 halves. So we can count those 2 halves all together as 1. So this would give us our 13th square. We can apply the same rule to the bottom right hand side and add those 2 halves together to give us 14. Again, the same unit of measurement per square, so the answer is 14 centimetres squared. Pause the video and have a go at estimating the areas of the 2 shapes on the screen in front of you. Okay, so the left one is probably the trickiest one to be able to go and work out, but let's stick to the same process we've been using before. Let's count all the whole or nearly whole squares that we can see. So these are going to be our almost full squares. So in total, we have 7 squares that are either full or almost completely full. Remember, we're estimating, so it doesn't have to be an exact answer. So we need to now consider these squares that we have here at the bottom, okay? Combining them together, they fill up almost half of the square, so combining them together would give us our 8th square. Now this one up here is a little bit trickier, but if we think that both of those covers up half of those squares, we can add those 2 halves together and we can count them as our 9th square between them. All we need to do now is have a look at the other squares on this corner. Now here we can assume that this is almost full and we have 2 extra parts that go across these 3 different shapes. So we can assume if we were to add those together, we will more likely have enough that's going to fill 1 square. So we can count this as our 10th square. However, we've got these sneaky teeny tiny bits on the side. Now we know if we added these small portions together, they are not likely to fill up a whole square. So we can go ahead and assume that's going to give us roughly half a square. So if we added them all together, our area would be 10.5 centimetres squared. Now this shape on here is a little bit easier. We can count all the whole squares. We know we have 6. If we look at the 2 corner shapes here, we know that those are 2 halves of a square because it's 2 triangles. So added together, those are going to give us a whole square as well. Now if we have a look at these 2 on the end, these 2 pretty much fill our whole square each. So I think it's fair to assume that we can estimate that they could be 8 and 9 squares. However, we have these teeny tiny little corners on the end that don't quite match up to half of a shape. So if we added them together, they roughly give us half of the shape. Therefore, 9 would be a good estimate, but an even better estimate would be to take away that additional half of the square. So our answer could be either 9, but even better would be 8.5 centimetres squared. Now, this is a very tricky shape, okay, so it's important to make sure that we take this nice and slowly. So let's apply the same rules that we already know. Let's count the whole squares that we have on our shape. So if we count the whole squares and roughly squares that are pretty much full all the way to the top, we have 17 squares altogether. Adding this bottom one on the bottom gives us 18. So now we need to work out the areas of all those little missing boxes and see if we can piece them together to form our whole squares. So let's take these 2 on the corner, for example. They pretty much fill half of the shape. So if we add those 2 together, that's going to give us our 19th shape. If we have a look at this one here, this one is pretty much half of a shape. We also have half of a shape on this side. So if we combined the 2 together, that's going to give us our whole square. So we can count that as our 20th square. Now we have these 2 halves here, but what I'm going to do is I'm going to just tick off that one in the corner so I know that I've already done that one, so that I don't need to come back to that one again. So now we can have a look at the missing squares we have on this side. Now if you have a look carefully, each square here is a half of the square it's attached to. So if we add 2 halves together, that's going to give us a whole square. So those 2 combined gives us 21, and these 2 combined gives us 22. So now the only bits that I need to be looking at are these 2 bottom bits at the bottom. Now we can assume that they both fill up roughly half of a square each, so combining them together is going to give us the 23rd square. Now, one thing I need to pay very careful attention to is the measurement key here in the top corner. Now this tells me that 10 multiplied by 10 is going to be 100 metres squared, which means each square here is worth 100 metres squared. So that means if I have 23 lots of 100, my sum would be 23 times 100. Therefore, my answer is going to be 2,300 meters squared. So it's important to remember that you read the key at the top. That's going to tell you what each square is worth. Now it's over to you to have a go at doing the worksheet. Once you've had a go at the worksheet, please complete one of the 2 strips of questions from the Classroom Secrets that's been sent home to you. If you would like to have an attempt at doing the extension challenge, please also complete the extension challenge as well. The challenge question at the end is optional, but you need to make sure that you complete the worksheet attached to this PowerPoint and one of the additional strips of the questions that are sent home to you as well. If you feel like you need to give yourself an extra challenge though, especially those of you that know that you can do it, please have a go at doing the extension challenge. Good luck, Year 5.